So today we can talk about data sampling with sliding window. So we train LLMs to generate one word at a time. Basically, LLMs, what they do is they predict the next word. Okay. So while we are preparing the training data, okay, this is how we do it. So, for example, this is the training data, training text. LLMs learn to predict one word at a time. So how is it trained? First, the LLM, it receives the first word, LLMs, and it has to predict the next word, which is learn. Okay. So once it has predicted this next word, say learn, okay, so this becomes the part of the input to the LLM. So now the LLM, this large language model, gets these two words as input. LLMs learn, and then it has to predict the next word, which is to. Okay, and once it has predicted this, it becomes part of the input, and it has to predict the next word, taking these three input words, three words as input. LLMs learn to, and it'll predict the next word, and so on. Okay. So as you can see, this is the text sample, this whole thing, and this blue is the input the LLM receives, and these reddish, these are the words that the model has to predict, right? So these are the target to predict. So the LLM can't access the words past the target, so it cannot access these words that are past these targets. Okay, so now here we are reading this file called the verdict.txt, and then here we tokenize using tokenizer. We encode that raw text file, the contents of the verdict.txt. Okay, so this is encoded. Okay, and let's see how many tokens we get. So we have 5,145 tokens. These are the integer tokens because we're encoding, right? So we're encoding the contents of this raw text from the this file called the verdict.txt, and then what this does, tokenizer.encode, as we have seen previously as well. So what this does is it converts these raw text into the strings into integer, a list of integers. And then, so if you look at the number of integers in this enc underscore text, okay, there is 5,145. So for each text chunk, we want the inputs and the targets. So now we need to split our data kind of into training this the features and the target. Okay, so that is inputs. So these inputs and the target. Okay, so so let's see how we're going to do that. Okay, so here we're taking just some this 50 character onwards. Okay, so 50 character onwards. Okay, and we are setting the context size to be 4, and here x is the input. Okay, so we're taking encode sample. This is part of the this enc underscore text. So part of it. So we're just testing it out. So so we're taking from the encode sample, this sample. Okay, so we're taking here the first four characters, right? So first 4 characters, and then y, which is the target. We have from encode sample, we take 1 to context size plus 1. Okay, so 1 through context size plus 1. Okay, so here's the result. The result is x is 290. These are these numbers. Okay, and y is this. So this is the input, this is the input, okay, and that is supposed to be target. Okay, so as you can see, it's shifted by 1. So shifted by 1, so this x is this, and there is overlap in these 3 tokens, and okay, so these are the targets. So we'll see, okay, we'll see here, and then it will make sense in a moment. Okay, so here for I in range 1 through context size plus 1, okay, so we are taking the context as encode sample up to I, and then the desired, which is the target, is encode sample I. Okay, so here, so if you give, because we have prepared this, okay, from here using x and y, right? Using x and y. Okay, so let's see. So if you give 290 to the LLM, it has to predict, 4920. Okay, so this is the desired. Okay, this is the target. Ideally, it has to spit out, or it has to produce, the LLM has to produce 4920 given 290. Okay, and 4920 becomes part of the input right here. Okay, and then it has to predict 2241 ideally. Okay, and so on. Okay, so basically we have created this training set. Okay, training set which contains the inputs as well as the desired outputs. Okay, and we are converting these tokens back to words by using decode, tokenizer.decode, and here this exact same tokens, okay, convert it into words, and you can this makes more sense. Okay, so if you give and as input to the LLM, it has to output established, and established becomes part of the input. So and established is the input now, and it has to, the LLM has to produce or output himself, and himself becomes the part of the input to the LLM. Okay, and it has to output in, and so on. Okay, so now we'll take care of the next word prediction in a later chapter. Okay, so now let's see. Now, because this was just a test, right? So now we're going to use this idea to actually produce these training data. Okay, and then in the training data we'll have input as well as targets, right? The desired outputs. Okay, so here we're importing torch, and then so here is how it looks like when it works. So using the sliding window approach, okay, so let's see here. So for example, here, this is the sample text, right? And then this blue box is one of the inputs. Okay, so in the heart of, and then the corresponding target list is the heart of the. Okay, okay, and likewise. So here, so for example, when we do that, so we'll have list of inputs like this. So in the heart of, okay, and it's the sliding it's been this stride, something called stride. So the stride here is 4. So and then the next input is starts from the city stood the. Okay, the city stood the, and then again the next input will be all library, comma and a. Okay, and so on. Okay, so and then the targets. Okay, targets is in corresponding to this every input. It's shifted by 1 to the right. Okay, so for example here in this example, so in the heart of, so this is the input, and the corresponding target is shifted by 1. Okay, this is this exact same list but shifted by 1 to the right. Okay, so the heart of, and then the next word is the. Okay, and let's see, we're going to create a data set and data loader that extract chunks from the input data set. Okay, here we're importing data set and data loader from drawstr.utility.data, and here's the class GPT database v1 dataset. This is a class, right? Okay, here we are. This is the constructor which takes text as input, the tokenizer, the max length, and the stride. Okay, self-input IDs empty, self-target IDs, and token IDs is equal to tokenizer, this tokenizer dot encode, and then we're going to tokenize the text, and here allowed special is end of text. Okay, and using a sliding window to chunk the book into overlapping sequence max length. So we're going to go, so here's a loop, this for loop. Okay, so what this for loop does is it goes from 0 to the total length of the token IDs minus the max length, and they takes the stride, and the input chunk will be token IDs starting from I to I plus max length, and then target chunk is shifted by 1. See, it's exactly the same, but shifted by 1 to the right. Okay, and as we saw up there. Okay, and then self.input ID. So basically, we're turning those input chunk, which are list. This is a list. It's turned into a tensor. Okay, and it's appended to input IDs. Okay, list. This input IDs list. Likewise, target also same thing. We're going to turn these target chunk, which is a list, to a tensor, and then that tensor is appended to target IDs, which is a list. Okay, so and then here we have a couple of methods. The first is len method. So len, what it does is it returns the length of the input IDs. Okay, and then get item, it returns the if you give it the index IDX, so it returns the input IDs at that index, the provided index, as well as the target IDs of that index. Now let's create, we're creating another function called create loader, create data loader v1, which takes a text that size is 4 by default. These are the default values, of course. Max length equal to 256, stride 128, shuffle true, and so on. Okay, and here we can use the tokenizer, which is ticktoken.getEncoding GPT-2, which is a BPE encoder, as we discussed in the last video. Okay, and then here we're going to create a data set, GPT database v1, which is this one, instantiated. We're instantiating that using this text, text that we receive here, and then this tokenizer, the max length, which is 256 by default, and the stride is 128. Okay, and here we're creating a data loader. Okay, and then okay, we're providing the data set, which is this data set. Batch size is equal to batch size, shuffle equal to shuffle, drop last, and this, and it returns the data loader. Now let's test the data loader with a batch of 1 for LLM with the context size of 4. So here again we're reading this the verdict.txt, and then we're using this function called create data loader v1, which is this one right here, which is just discussed. And we are providing this raw text, which is batch size of 1, max length is equal to 4. Okay, and stride is 1, and shuffle equal to false. And then here, data iter, so we're creating an iterator. And the okay, so if we're trying to see the first input, the first batch rather, Okay, So here, okay. So when we run this, we get these two tensors. Okay. Okay. So here, this first tensor, which is the input, and this is the target. Okay. So you can see there's overlap 367, 285, and 1464, and since the target is shifted to the right by 1, so there's a this is a new token that was not here. Okay, so and then likewise, let's print the second batch. The second batch is 367, 285. So because there's a stride of 1, so that's why we're still seeing these. Okay, so 367, 285, 1464, 1807, and this is the target input and the target, and so on. Okay, so here an example of using stride equal to the context length. So here, if you're using the stride length of 4, so the context length 4 and the stride of 4. Okay, so so this is this one right here. So the first input is in the heart of. Okay, because the context length is 4, and the stride, since the stride is 4, the next input begins after the 4 tokens 1, 2, 3, 4, and here the city is 2, and so on. Here, if you have a stride of 1, it's the next token, that's the next set of inputs. Start as the next, so off by 1 here. Okay. So and here, okay, let's see another example here. So we're going to use data loader raw text. Here we have a batch size of 8, max length 4, stride 4. Okay, so here, as you can see, this is in every batch. So this is one batch. Okay, so this is the set of and this is the inputs. These are the inputs, and these are the corresponding targets. Okay.